Hi everyone. Today we're going to talk about the spatial connections in Earth systems. So let's get started. So Earth systems are actually linked across distant spaces. Earth systems are linked globally, and local changes that happen in Earth systems can actually influence much distant regions. And understanding these patterns helps us explain global change. Earth's surface is actually very uneven. Land, oceans, and life are not evenly distributed. Places like the tropics near the equator have high biodiversity, meaning there's diversity in the types of organisms that exist there. And normally, these are places where carbon is being cycled between life, soil, the atmosphere, and so on. If we look at polar regions near the North and South Pole, these places have much lower diversity and biodiversity. They're not that a lot of there's not a lot of diversity that exist in the types of organisms that exist in these regions. But these places are major places where carbon is being stored in the ice or the permafrost. As we mentioned before, certain parts of the Earth's surface are not even. Some places are carbon sources, meaning these places release more carbon into the atmosphere, and certain places are carbon sinks. These places absorb more carbon from the atmosphere. For example, places that are considered carbon sources are places that have high fossil fuel burning or high deforestation. And carbon sinks, an example of that would be oceans, forests, soils, where lots of carbon is being absorbed from the atmosphere. So, spatial patterns impact the global carbon dioxide balance depending on the region that you're in. Some places are carbon sources versus carbon sinks, and this helps us balance the carbon dioxide level globally. Energy and matter move throughout the globe through our ocean currents and our global belts. Dust, heat, and water move between continents through our water and our wind currents. Weather and climate are shaped by global flows of these ocean and wind currents and help connect the regions of the Earth systems globally. There are also connections between biotic and hydrologic parts of the Earth system, meaning the life of the Earth system as well as our water. For instance, animals migrate globally, and this connects distant ecosystems. Rivers and ocean currents transport water and nutrients throughout the globe. Life and water link land, ocean, and the atmosphere. Events in one place can actually affect distant regions through our through our ocean currents as well as our wind belts. For instance, let's talk about the El Nino and La Nina shifts. Normally, you'll see that our ocean currents move or circulate a certain way, and this can also affect how our wind belts move. And you see that normally, because our ocean currents and wind belts move this way, Australia will have warm rising air causing thunderstorms, and then South America will have dry sinking air causing droughts. But then during El Nino events, these currents, the direction of these current ocean currents, as well as our wind belt, shift. And this can affect the climates of these regions as well that are for a large distance from each other. This shift can, as you can see in this area, causes warm rising air and thunderstorms in South America, and now dry sinking air causing droughts in Australia. So, Earth's systems communicate through the atmosphere and our oceans, and it can impact the climate and weather patterns globally. Why do these connections matter? Well, one local disruption can trigger global change. For instance, deforestation and the melting of ice. If we're talking about the melting of ice, the large scale melting of ice in the North Pole is actually affecting the Atlantic Meridional Overturning Circulation, or the AMOC, which is a global network of ocean currents in the Atlantic Ocean. Normally, the movement of the current ocean currents in the Atlantic Ocean regulates the climate in the regions nearby the Atlantic Ocean, where warm water and cold water is flowing and balancing the climate of these regions. But because we're melting ice on a large scale in the North Pole, it's actually also affecting how the this circulation of ocean currents move, and in turn is also affecting the climate in these regions nearby. So one disruption in the North Pole, the ice in the North Pole, is also disrupting or triggering global change. So predicting Earth system behavior requires not only a local view, but a global view, because everything is interconnected. And this helps us understand cascading effects of our human activity, the changes that we're making to the Earth's systems locally, because they are not just local, they're also global. In the next video, we're going to talk about tipping points and what happens when the Earth's balance breaks. What happens when Earth systems pass its critical limits because of all these changes that we're making to the Earth systems? How do feedback loops lead to rapid and even irreversible change? So that's it. Thank you.